Hi everyone. This is a really quick video over Chapter 16. Chapter 16 is really short and it just introduces a few vocabulary words. We talked previously about statistical significance versus practical significance, and that will come up in your Chapter 16 homework. The other vocabulary that we're going to talk about in Chapter 16 are types of errors. We have two types of errors, a type 1 error and a type 2 error. I know, really interesting names. So this happens depending on our conclusions that we make with our hypotheses tests. So if we reject the null hypothesis and we're wrong, then we've made a type 1 error. And if we fail to reject the null hypothesis and we're wrong, then we've made a type 2 error. No conclusions that we're making when we're running hypothesis tests or finding confidence intervals, we're not concluding anything with 100%. We're not 100% confident in anything that we're doing, which means there's always a chance that we're wrong in our conclusion. And so if we reject the null hypothesis and we say we have evidence against that, but it turns out that the null hypothesis is actually true, then we were incorrect and we made a type 1 error. But if we fail to reject the null hypothesis, we say we don't have evidence against it, then it turns out that the null hypothesis is false, then we've made a type 2 error. So I have like a little table here that describes the different, what can happen with our conclusions, the different scenarios for our conclusions. So if we reject the null, but it turns out that the null was true, then we've made a type 1 error. But if we reject the null and the null is actually false, then we made the correct decision. If we fail to reject the null and the null is true, then again, we've made the correct decision. But if we fail to reject the null and it turns out the null was actually false, we've made a type 2 error. So I have an example here where I don't include any numbers because I really want to talk about the types of error in the context of the problem. So this example says, have harsher penalties in ad campaigns increase seatbelt use among drivers and passengers. Observations of commuter traffic failed to find evidence of a significant change compared with 3 years ago. So we're going to start by talking about the hypotheses, but because I don't have any numbers, I'm going to write these hypotheses in words, in general terms. So remember that the null hypothesis is that nothing has changed. So we would say that the null hypothesis is that seatbelt use among drivers and passengers has stayed the same, regardless of these penalties and ad campaigns. Whereas the alternative hypothesis is that a change has occurred. So we would say that the seatbelt use among drivers and passengers has increased because of these penalties and ad campaigns. Now we want to explain a type 1 error. And remember that a type 1 error occurs when we reject the null. We reject the null and we say we have evidence for the alternative. So in the context of this problem, we would say that we would claim that we have evidence that seatbelt use has increased when in fact it's remained the same. A type 2 error happens when we fail to reject the null, and then it turns out that the null is actually false. In the context of this problem, that would be that we claim that the seatbelt use has stayed the same. We don't have any evidence that there's been a change. But in fact, the seatbelt use has actually increased. One of the questions that we ask is which of these types of error is worse in this scenario? This one, I think you could argue it, but I'm saying that a type 1 error is worse. So to say that we think that seatbelt use has increased and therefore more lives have been saved when we're actually wrong and we're not actually saving more lives, that's worse than a type 2 error in this context. So why do we want to talk about which type of error is worse than the other? The reason for that is that we will choose our significance level based on trying to mitigate the worse error. So the probability of a type 1 error occurring is equal to our alpha level. So if we have a standard alpha level of 0.05, then we have a 5% chance of making a type 1 error. The probability of making a type 2 error is called beta, and it's a different calculation, and not something that I want to go into in this class. It's not, it's above this class. So if the probability of having a type 1 error is equal to the alpha level, and we've determined that a type 1 error would be really bad, then we want to make sure that we choose an alpha level that's really small so that the probability that we create this error or that we make this error is smaller. So if we're talking about life and death situations, we're more likely going to pick an alpha level of 0.01 or 0.001 so that we reduce the probability of making that type 1 error. So we're going to just do a quick example, recap hypotheses tests, and then talk about the type of error that we could have made. So this example says a company is willing to renew its advertising contract with a local radio station if the station can prove that more than 20% of the residents of the city have heard the ad and recognize the company's product. The radio station conducts a random phone survey of 600 people and finds 133 people that recognize the product. At a significance level of alpha equal to 0.05, discuss what the survey reveals about renewing the contract. All right, so here's our sample, and here's that population proportion that we're wondering, is it this or is it something more than this? So our null hypothesis, we're talking about proportions, so we're going to use a P, is equal to 20%. And the alternative hypothesis is that more than 20% will recognize this company and their product. So we're going to run a 1 prop Z test. The null proportion is 0.20. The X is the number of successes, that's the 133. The N is 600. And then we want to know if the prop is greater than 0.2. And when you run this test, you'll get a Z-score of 1.327. So that's our test statistic, just above 1 standard deviation. That's not that unusual, so we get the probability of observing this is 0.0923. So our p-value is above the significance level of 0.05. So we would say, since the p-value is above 0.05, we fail to reject the null hypothesis and conclude that there is not enough evidence that more than 20% of people recognize this company's product. Can you hear my puppy in the background? Okay. So again, we have this, we're above the significance level, so we fail to reject the null hypothesis and conclude that there is not enough evidence for the alternative hypothesis, that more than 20% of people recognize this company's product. So that basically means they're not going to get, what does it say? They're not going to renew this advertising contract. So the company will not renew the contract. What type of error can occur in this situation, in this context? Remember, we have a type 1 or a type 2. Type 1 happens when we reject the null, and a type 2 happens when we fail to reject the null, or could happen. So we would say that a type 2 error, you can use the Roman numerals or the number 2, but a type 2 error can occur since we failed to reject the null.